Hello and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 5.2 for Intro to Statistics, considering the difference between the observational studies versus experiments. We've dealt with observational studies in the past, but an experiment is more unique to studying two or more variables. An experiment is a type of study used to investigate the possibility of a causal connection between the explanatory and response variables, in which individuals are assigned to a treatment. We also have a specific randomized experiment as an experiment where individuals are randomly assigned to a group. In essence, an experiment is where the researcher intentionally changes or controls certain variables to determine how one or more variables influence another. In stark contrast to an observational study, where the researcher tends not to change any variables, and instead either observes nature in its normal form or simply asks questions. Remember from last section that association does not imply causation. In a data analysis, association does not imply causation, and causation can only be inferred from a randomized experiment. This is why experiments are important. If we can control variables, we have less of a risk of lurking or confounding variables being an issue with our conclusions. Note that I say less of an issue, as confounding variables can still exist in experiments too, if not controlled or even considered. However, because of that controlling aspect, this allows us to say in experiments that a causal connection can be made between an explanatory variable and a response variable. However, when constructing an experiment, there are four primary principles of experimental design that should exist in all good experiments to some degree. The first principle is that of controlling. This means that researchers assign treatments to observational units, and they do their best to control any differences in the groups. What this means is that we're trying to make sure that in the multiple groups that we'll have in a study, that we control any differences between them. So any differences of variables that we are not trying to analyze are as minimized as possible. The second principle is that we will have randomization. This means that researchers randomize patients into at least two treatment groups to account for variables that cannot be controlled. Now, remember that I've said that we will be able to control some variables to some degree, but we still have a possibility of lurking or confounding variables. This is why we will set up both what is called a treatment group and a control group, and we want to randomize which individuals go into each of those groups. Thirdly, for the principles, we have replication. This means that the more cases the researchers observe, the more accurately they can estimate the effect of the explanatory variable on the response. In a single study, we replicate by selecting a sufficiently large sample. Overall, as long as we have a large enough sample, or if we have replicated the data, done the experiments again, then we have replication. Lastly, we also have blocking. Researchers sometimes know or suspect that variables other than the treatment influence the response. Under these circumstances, they may first group individuals based on this variable, then randomize observational units within each block to the treatment groups. This strategy is often referred to as blocking. For instance, if we are looking at the effect of a drug on heart attacks, we might first split patients into low-risk and high-risk blocks, then randomly assign half the patients from each block to the control group and the other half to the treatment group. Overall, if we believe that there might be something else going on, then it would behoove us to make these kinds of blocks to try to minimize the results of them. Or, if we find that those blocks are an important factor, we can include those as a variable of interest. We have a few more definitions to tie these aforementioned principles together and specify parts about them. We have first the different types of groups, which we have already been relating to. We talked about what is called a treatment group and a control group. A treatment group is the group that receives the drug or the treatment being tested if we're not talking about a medication study in an experiment. And the control group is the group that did not receive any treatment or standard treatment in an experiment. Oftentimes, the control group is the group that is either given in a medical study a sugar pill or something that is not meant to influence them, or if we're talking about a non-medical study, maybe we ask them to sit in a room quietly to try to simulate no change. We also have the concept of blindness. When we talk about blind, we mean that researchers keep the patients uninformed about which treatment they are receiving. It can be a potential issue with confounding variables if the patients are aware of whether they are in the treatment group or the control group. On the next page, we have at the top a placebo. This is what we refer to as a fake treatment, such as a sugar pill made to look like the actual treatment pill. And tied with that, we have the placebo effect, when a placebo results in a slight but real improvement in patients. This is a very common side effect that happens, particularly in medical studies, and tends to be an example of how powerful the mind is over the body. Our last definition here is for double-blind, an extension of the previous blind definition. When doctors or researchers who interact with patients are, just like the patients, unaware of who is not receiving the treatment. There can also be possible bias that can come in if the doctors are aware whether their patients are receiving the treatment or not. And so we try to minimize that by also making sure that they don't know who under their care is receiving the treatment. If they know and they have a personal connection, they could change who receives treatment. Let's look at an example of all this. A researcher is interested in the effects of exercise on mental health, and he proposes the following study. Use stratified random sampling to ensure representative proportions from 18 to 30, 31 to 40, and 41 to 55-year-olds from the population, and next randomly assign half the subjects from each age group to exercise twice a week, and instruct the rest not to exercise. Conduct a mental health exam at the beginning and at the end of the study and compare the results. The first question of whether this is an observational study or an experiment, we have to ask ourselves if there was anything done to the individuals. If it's an observational study, that means that nothing new was introduced, nothing was applied to the observational units we are working with. However, in this case, the individuals that were gathered, some of them were told to exercise, some of them were told not to exercise. This is a change and therefore an experiment. As for the 4 principles of experimental design, we first have the concept of controlling. For controlling, we notice that there is a treatment group and a control group here, and it seems like the individuals, the researchers, are trying to control any other differences. All they're trying to show is that some get exercise and some do not. So they are applying a treatment and trying to control any other differences. For the second principle, we have for randomization, they were randomly assigned into treatment groups and into control groups. It was explicitly stated in the description in the third sentence. For the third principle, for replication, it's not as clear, but it says that we have representative proportions for all of the groups that we are working with, which does tend to imply that we do have a large enough sample, although we would like a little bit more clarity here on how large the sample is, or if this situation was replicated by somebody else. Lastly, we have for blocking that we first split everything into different age groups, the 18 to 30, 31 to 40, and 41 to 55, trying to see if that could be a possible issue. Those age groups are our different blocks. For the last question of if there are statistically significant results, Can we conclude that exercising causes improved mental health? We keep in mind that this is an experiment, and one of the benefits of working with experiments over observations is that we can try to make a causational connection. And that's exactly what this question is asking for. Can we conclude that exercising causes improved mental health? So what we're going to say in response is that yes, because this is an experiment, we can claim one variable causes another. If you have any further questions, be sure to review the example videos or ask your instructor.